All right, so tonight we are going to talk about rational numbers. Now, I want to kind of talk to you about numbers in general. Way back when, in the beginning of time, we had numbers. Now, they may not have looked like the numerals that we're familiar with, but we actually did have a number system. And these numbers were actually very natural to the people who used them, so yes, they were called the natural numbers. And these were the counting numbers, 1, 2, 3, and so on, all the way up to whatever you can come up with. So these were called the natural numbers. Now, you will notice that there is a number missing from here. And that number is, in fact, what? Correct. It is 0. 0 is not natural. Now, to us, you would think, well, how do you write the number 10 if 0 isn't there? But in actuality, they didn't use 0 to write 10 because we used the Roman numerals, and in Roman numerals, 10 is an X. There was no 0. So they didn't need it. It wasn't until much later, like with the ancient Babylonians or Mayans, there's actually a debate on who it was, that actually came up with this concept of 0. And 0 became this new number. And so what they did was, because mathematicians don't like having two separate systems, they created what was called the whole number system. And the whole numbers were 0 and all the natural numbers. Now, after we have the whole numbers, we started doing this thing where we would do a countdown. 3, 2, 1, 0, uh-oh, we don't have a number below 0. But we did, and we created a brand new set of numbers, and those were known as the integers. And those were our negative numbers. But again, we don't like having separate sets, so we took the negative numbers, put it with the whole numbers to create the integer set. Now, the story goes, made up story goes, but the story goes that one day there was a king sitting around and someone came with a huge machete and cut right through an apple sitting on his table and ran away with part of the apple. And everyone stood there because no one knew how to describe the apple. And in reality, it was, as we know, would be half the apple. But half made no sense to people. So we had to come up with a new kind of number. Numbers like 1/2 or 0.5, decimals that would stop, they terminated, or decimals that might repeat. These are all special kind of numbers because they are all numbers that actually have something in common. And what's in common is that they all can be written as A over B. They all could be written as fractions. But these were known as the rational numbers. And of course, we'll put them together with the integers. And we have our big set of numbers. Now, hold on. Okay, so this is where as I said, this is where we're going to stop for this lesson, but I just would like to show you a few other things, because there are other types of numbers. There are some numbers that we have that just don't fit the rational mold. They're numbers like pi, or 0.278593464287948321872495313624 Yeah, numbers that go on and on and on and on and on. These were known as irrational numbers. And again, numbers like pi, or the square root of 2, or 0.3487, and so on, that never end. And these were known as the irrational numbers. Now, I wanted to move those up a little bit. Now I know what you're thinking, though. And you're thinking, haha, that's really funny. You know, rational numbers, irrational numbers, not funny yet, I take that back. But as we said, mathematicians don't like two sets of numbers. So they put them all together, and they came up with a system that we call the real number system. Now you're probably laughing to yourself, going, ha ha ha, real numbers, that's got to be funny. There must be fake numbers too. There are. That's right, ladies and gentlemen, there are things called fake numbers. Those numbers are numbers that are like this, the square root of negative 1. Because try to come up with a number that times itself will give you negative 1. I know you're thinking about that, and it doesn't work. Because think, 1 times 1 is positive 1, and negative 1 times negative 1 is positive 1. So we called these imaginary numbers. And of course, we don't want to have two sets of numbers. So, oops, let's try a different color there. Okay, how about erasing it? There we go. So again, we take our set of real numbers and our set of imaginary numbers, and we throw them all together to make the complex number system. Now, like I said, today we're only stopping at the rational numbers. But do be aware that with rational numbers, for example, if something was rational, it's rational. But if it was a natural number like 5, it's also a whole number, an integer, and a rational. So you could start with an inner box and keep going out, but you can't jump back into a box. So that's something that you should be aware of. Now, one of the things that we're talking about in this section is how do you turn a decimal into a fraction? Like, for example, how do you turn 0.27 into a fraction? Well, it's actually really simple. See, I say this 0.27 because that just kind of is the way we read them, but that's not true how you're supposed to read them. If you read this properly, you would read this as 27 hundredths. Well, if you think about what I just said there, 27 hundredths is a fraction. And now I've just converted a decimal into a fraction. But beware, 0.84. That's what? Yes, 84 hundredths. But you're wrong. It's not, because it can be reduced. And I could divide both by 4, and I will get 21 25ths. And that gives me my fraction in simplest form. Now, one of the things that happens is getting something like 0.6 repeated. And how do we deal with repeated decimals? And how do we turn a repeated decimal into a fraction? Well, to turn a repeated decimal into a fraction, we're going to use a little trick. And the trick is we're going to start by letting n equal this repeated decimal, and so on and so on. Now what I want to do is I want to multiply this repeated decimal by a factor of 10, or hold on. Okay, so we left off with we wanted to make this repeating decimal. I want to change it so that I get a whole number in the same repeated decimal. Well, the way to do that is to move the decimal over one space. So I get 6.6666. Well, moving a decimal over one space like that is the same as multiplying it by 10. So I want to make sure that if I multiply one side by 10, I multiply the other side by 10. And I get 10n. Now here's where it gets cool. I'm going to take these two equations basically, and I'm going to subtract them from each other. If I have 10 n's and I take away an n, what I'm left with is 9n. If I take 6.66666 and subtract 0.66666, all those 6's cancel out, and I'm left with just a 6. Now I have 9n equals 6. I can divide both sides by 9, and I get n equals 6/9, or n equals 2/3. And that is changing a repeating decimal into a fraction. Now, I'm going to give you one that I want you to try, and this is the one I want you to bring into class on Monday. So would you try to turn 0.42 repeated into a fraction? See you then. Bye-bye.